This is our second lesson in Unit 6-7, factoring, and this is the first lesson where we're actually going to do some factoring. So here's what we want to be able to do by the end of this lesson. We want to be able to factor a common term out of a polynomial. And this is probably the most important thing to be able to do. We want to be able to factor a common binomial out of a polynomial, and we want to be able to factor by grouping. And these last two, well, factoring a common binomial is going to lead us into factoring by grouping, and factoring by grouping is going to become important later when we are factoring what we call harder trinomials. Trinomials has an N in it. Okay, and we're going to be doing that in the lesson for section E, so a little ways down the road. So let's start by remembering what we did in the previous lesson when we were doing expanding. Okay, we had something like this, x times x minus 4, and we were using the distributive property. We were taking this x out front, and we were multiplying it by both of the terms that were in the brackets there. X times x would get us x squared, x times negative 4, negative 4x. So we're basically taking something that is a product, okay, two things multiplied together, so the x times the x minus 4, and we are turning it into a polynomial, a sort of a list of terms, okay? And this is called expanding, okay? And we could do this a little bit more, make this a little bit more complicated. If we had 3x, and we're multiplying it by 2x squared minus 5x. First we do the 3x times the 2x squared. We're going to multiply the coefficients. 3 times 2 gets us 6. And we are multiplying two powers with the same base. So we're going to keep the x, and we're going to add the exponents. X to the 1 plus 2 gives us x cubed. 3 times, right, and then we're going to do our second multiplication here, 3x times negative 5x. The 3 times the negative 5 gets us negative 15. The x times the x, adding the exponent, is going to be x squared, because that's an x1 and an x1. Okay? And in this one, we're doing the same thing again. We're taking our product, 3x times the stuff in brackets, and we are expanding it out to get a polynomial. What we want to do in factoring is we want to do the opposite of what we were just doing in expanding. We are going to start with a polynomial, and we want to write it as a product of two or more terms. Okay, so let's look at an easy example first, 2x plus 4, 2x plus 8. We want to first figure out what is common to all of the terms that we have in our polynomial here. So we want to look at the numbers, and we want to look at the variables. Okay, so let's look at our numbers first. We've got a 2 and an 8. Is there a number? Can 2 and the 8 both be divided evenly by the same number? Is there a number that divides evenly into both 2 and 8? And there is. They can both be divided by 2. So 2 is common. It's like a common factor of those two terms. So we're going to write the 2 out in front. And then what we need here is, in the brackets, we need two terms. We need a term here such that when we do 2 times that term, we end up with our 2x. Okay? And that's just going to be an x. 2 times x gives us 2x. Over here, we need a term so that when we do 2 times that term, we end up with the second term in our original expression. So 2 times what gives us 8? Well, that's got to be a 4. 2 times 4 is 8. Because if we were to take this 2 times x plus 4, and we were to do the expansion, 2 times x is 2x, 2 times 4 is 8, we'd get back to the thing that we started from. So we want to take this thing that is multiplied, that is 2x plus 8, and we want to multiply it as, write it as something that is like 2 times x plus 4. Now, when I'm writing out the steps here, I said the step 2 is divide each term by the common term. I mean, we could have done this just a little bit more explicitly by saying, okay, our 2 is common. We're going to take our 2x and divide it by the 2. And we're going to take our 8 and divide it by the 2, because the fact that the 2 was common meant that both of these terms were divisible by 2. 2x divided by 2 is x. 8 divided by 2 is 4. So we still get the same thing, x plus 4. It's usually easier, though, just to think about what needs to get multiplied together to give us the answer that we want. So let's take a look at our next example here. We've got 3x plus 12x, and we want to look at what is common to these two terms here. Well, we'll start with the numbers. We got a 3 and we have a 12. Both of those are divisible by 3, so we've got a 3 that is common to those two terms. If we look then at the variables, we've got an x squared and an x. We always take the lowest power of this variable that is common. So x is common to both of those terms. And we'll just put a note here that said it's the lowest power that we see. Okay, so x is common, x squared is not common. So if these two things are common, 3 and x, when we factor this, we're going to need a 3x out front. And then inside the brackets, we need two terms because we started with two terms. So we've got one here, there, here, and here. And we have to think, okay, 3x times what gives us 3x squared? Well, we need an x in there because 3x times x is going to give us 3x squared. In our second term, we've got to think, okay, 3x times what gives us 12x? Well, we already have the x taken care of, so we don't need an x in there. We just need a number 4. 3 times 4 gives us the 12, and we already have the x taken care of. Our next one here, 16x cubed minus 12x squared. Okay, let's start by thinking about what is common between these two terms. Common. All right, let's look at the numbers first. Is there a number that divides evenly into both 16 and 12? Yes, there is. That number is 4. We've got an x cubed and an x squared, so we have x's that are common to both of the terms. We're going to take the lowest power out of those common powers. So the lowest power is going to be x squared. So we're going to have a 4x squared. And we're going to have two terms in brackets. I might as well put in the negative sign there because we know that that second term has to be negative. And we need something in here that when we multiply 4x squared by that term, we get 16x cubed. We can think about this in terms of the numbers and the variables. So 4 times what gives us 16? That's got to be 4 times 4. X squared times what gives us x cubed? We've already got 2 of the x's taken care of. We just need one more x to give us the x cubed. X squared times x gives us x cubed. In our second term here, we need something in here that when we multiply 4x by that, we're going to get 12x squared. Let's start with the numbers. To get a 12, we're going to have to multiply our 4 by 3. And x squared times, well, we already have the x squared taken care of. So we just need the 3 in there. 4x squared times negative 3 gives us this negative 12x squared. And we can make this more complicated by adding in more variables and by adding in more terms, but we do it the exact same way. So here we've got 12a cubed b plus 8a squared c minus 4ad. Let's start by what is common in terms of the numbers and in terms of the variables. So we look at all 3 of these terms, 12, 8, and negative 4. Those numbers are all divisible by 4, so a 4 is common to all those terms. When we look at the variable parts, they all have an a in them. So an a is definitely common. And what power of a can we factor out? Let's look at the lowest power that we see. We've got a cubed, we've got a squared, and we've got a power of 1 there. So we can just factor out a to the power of 1. So we write that common term out front. And then Inside the brackets here, we're going to need 3 terms. We started with 3 terms, so we need 3 terms inside the brackets. And we have to figure out, okay, what goes in here is going to give us, when we do this multiplication, 12a cubed b. Well, start with the numbers. 4 times 3 will give us the 12. Then let's move on to the a's. We've got 1a taken care of out here. We need a total of 3, so we need a squared. We need a b. We don't have any b's factored outside, so we need a b in there. In our next term, let's think of the numbers. 4, what goes in here so that we can get this term here? Well, we need to multiply our 4 by 2. We already have one of the a's taken care of, so we need another a in here. A times a will give us the a squared, and we don't have a c yet, so we'll have to have a c in there. And then our last term, we're looking at what goes in here, so that when we do this multiplication, we end up with negative 4ad. We've already got the 4 factored out. That's taken care of. We've already taken care of the a to the 1. It's just the d that we need in there. So that is common factoring. Okay? So at this point, if you're following along in the learning guide, you could go ahead to page B3 and try the questions that are in practice number 1. And these are all just common factoring questions. We will look, this is actually, I think this is 1A here. We just look at what is common to these two terms. Both of our numbers are divisible by 3, so we'll bring a 3 out front. And what do we need inside our brackets? We need 2 terms, a 3 and an x, because 3 times 3x gives us the 9x, and a 5y. 3 times 5y gives us the 15y. Okay? So work your way through those practice questions, and then we'll continue with the next kind of factoring. Now, the next kind of factoring is the idea that the thing that is common between our two terms doesn't have to be just a single term. It can be a binomial. So let's look at the one on the left here. 4x times w plus 1 plus 5y times w plus 1. We still have sort of just 2 things here, okay? Like sort of 2 terms that we're working with. What is common between these 2 terms? It's this entire w plus 1 expression here. So just like in the last ones, we're going to take that thing that is common, the w plus 1, and we're going to bring it out front. And then inside our brackets, we need 2 terms because we started with 2 terms, right? On either side of that dotted green line, all right? And what we need is, in here, we need, what do we have to multiply w plus 1 by to get 4x times w plus 1? Well, obviously we need a 4x. What do we need over here so that when we multiply w plus 1 by it, we end up with 5y times w plus 1? Well, obviously 5y. So there's our factored form. W plus 1, 4 times 4x plus 5y. So we've taken our thing where we've had 2 terms added together, and now we've written it as 2 things that are multiplied together. Taking a look at the one on the right here, we've got x times a plus 7 minus a plus 7. Again, we've got 2 terms here. Here they're subtracted instead of being added, but we notice that the a minus 7 is common to both of these terms. So we can factor out a plus 7. In the brackets, we're going to have 2 terms. Again, because we had 2 terms to start with. Our first term, a plus 7 times what is going to give us x, a plus 7? Well, that's just going to be the x. For our second term, we have to do a plus 7 times what to give us this negative a plus 7. It looks like we already have everything that we need, but we can think of this as having like a negative 1 out in front here. Okay? So what we're going to have in here is just the 1. Like we need something after that negative sign in that bracket, so it's just going to be a 1. A plus 7 times negative 1 gives us negative a plus 7. Okay, so you can try those ones on page B3, practice number 2. That'll just help you give you some practice factoring out a binomial term. Finally, we can take both of these types of factoring and we can combine them together. Okay, this is what is called factoring by grouping. Now, what we're going to do here is let's look at this first one here, 2x plus 2y plus x squared plus xy. Okay, we ask ourselves, is there anything common to all terms? Well, no. There's some with x's, there's some with y's, there's some with 2's, but there's nothing common to all 4 of those terms. If there's nothing common to all 4 of the terms, and you have 4 terms, you can try grouping the first 2 terms together and then just common factoring those ones. So if I just look at those first 2 terms, what is common to 2x plus 2y? Well, the 2 is common, and then in the brackets I'll need x plus y. So 2 times x plus y. I can then group the second 2 terms together, and I can ask myself, okay, what is common to those second 2 terms? Well, if we've got an x squared and an xy, the x is common. What I'm going to be left with in the brackets after factoring out that x, I'll have an x here, and I'll have a y here. Now when I look at these, I have an x plus y and an x plus y that's common to these 2 terms. So I can factor out the x plus y, and I'll be left with 2 plus x. So first we group them together, first 2 terms and the last 2 terms. Then we common factor. So let's say group 2 terms. We common factor those groups of 2 terms, and then we factor the binomial. Factor the binomial out. Okay. So let's look at another example here. We've got x squared plus 3x plus xy minus 3y. Let's get rid of this. That's a little bit better. Okay. X squared minus 3x plus xy minus 3y. Is there anything common to all 4 of those terms? No, there is not. So let's do our grouping. We're going to group our first 2 terms together, and we are going to group our second 2 terms together. And we're going to look at those blue terms there, and we're going to common factor. What is common to those 2 terms? And x is common. We're going to need 2 terms in the brackets there. X times x will give us x squared. X times negative 3 gives us the negative 3x squared. Plus. Then we're going to factor our red terms. What is common to those 2 red terms? The y is common. We need 2 terms in the brackets here. An x and a 3. Y times x gives us xy. Y times negative 3 gives us negative 3y. Having done that, we have an x minus 3 term that's common to those 2 terms that we have now. So if we factor out x minus 3 from that first term, we're left with an x. If we factor out an x minus 3 from the second term, we'll be left with the y. So x minus 3 times x plus y. And finally, our trickiest one here, 3y minus 5x minus 3 plus 5xy. First we look at it, there's nothing common to all 4 of the terms. We can group our first 2 terms together, and we can look to common factor them. But once we've done that, we notice that there isn't anything common to those first two terms. So what we have to do in this case is we're actually going to rearrange the terms before we factor by grouping. Because these terms are just added or subtracted, I can change the order, making sure I don't change the signs on the terms. So I'm going to write this as 3y minus 3 minus 5x plus 5xy. Then I'm going to group these two terms together, and I'm going to group these two terms together and try to do my common factoring. So for those blue terms, the 3 is common. I'll be left with y minus 1. Okay, 3 times y gives me 3y. 3 times negative 1 gives me negative 3. What about those red terms? Well, I see a 5 that is common to both of them, and I see an x that is common to both of those terms. So if I factor out a 5x, I need to get a negative 5x here. So 5x times negative 1 will give me negative 5x. And then 5x times y will give me the 5x times y. Now, you might look at this and say that my binomial is not common, but I can rearrange these two terms because they're just added together. So I can rewrite this as 3y minus 1 plus 5x, and instead of negative 1 plus y minus 1. Now it becomes obvious that the y minus 1 is common to both terms. So we can factor out the y minus 1. And what are we left with? We're left with the 3 plus the 5x. So we've got our written in our fully factored form.